Today, we're going to dig into a really fascinating idea in AI called BEMYEYES. This is all about how a super clever team of specialized AIs can actually outperform one single massive model, not through brute force, but through teamwork.
To really get this, just think about this question for a second. What if the smartest mind in the world couldn't see? It's a pretty wild thought experiment, right? And it perfectly sets up the huge problem that some of the most advanced AI on the planet are facing right now. See, on one side, you have these incredibly powerful large language models, or LLMs. They are absolute wizards with language and logic. They can write beautiful poetry, they can churn out complex code, but then you ask them to do something simple, like identify a plant in a drawing, and they can't. They have this massive blind spot.
And that's the bottom line. For all their brain power, these AIs are what's called unimodal. They only understand text. So in a very real way, they're blind. And that's a huge problem when you're trying to operate in a world that is, overwhelmingly visual.
So, what's been the solution so far? Well, the standard playbook has been what you could call the all-in-one approach.
The idea sounds kinda logical, right? Just build one gigantic, multimodal model that can handle both vision and language from the get-go. Train it on absolutely everything so it can do everything. This is pretty much the path that models like GPT-4o have taken. But here's the catch, and it's a big one. This one model to rule them all approach has some serious downsides. I mean, the amount of computing power and data you need is just astronomical, which makes it insanely expensive. And maybe the most shocking part, when you try to cram everything into one model, its pure reasoning skills can actually get worse than its text-only cousins.
And that brings us to this brilliant new strategy from the BEMYEYES framework. Instead of building one giant, what if you built a multi-agent dream team?
This is such a great way to visualize it. The team is just two specialists. You've got a perceiver, which acts as the eyes, and a reasoner, which is the brain. Each one has a very specific job, and they are incredible at it.
Okay, so first up is the perceiver agent. This is a pretty small, very efficient vision language model. Its only job, literally its only job, is to look at an image and just describe what it sees, factually. Think of it like a field reporter, just sending back the visual intel. Then you've got the reasoner agent, aka the brain. Now, this is one of those super powerful text-only LLMs we were just talking about. It can't see the image at all, but it doesn't need to. It takes the text descriptions from the eyes and uses its massive knowledge base and top-tier reasoning skills to figure out the solution.
And the way they work together is so simple, it's genius. A user asks a question with an image. The eyes agent looks at it and just describes what it sees to the brain. The brain, using its powerful logic, might ask clarifying questions, like, hey, can you tell me more about the shape of the leaves? And through this simple conversation, they team up to find the answer.
I know this might sound a little abstract, so let's just walk through a real example from the research paper. You can see just how powerful this whole conversational thing really is.
All right, here's the test. A user uploads this botanical illustration and asks, which angiosperm species is this? Now, this is tough. It takes a good eye for detail and some pretty specialized knowledge about plants.
So, first up, the eyes agent gets to work. It doesn't know the answer, but it gives a perfect description. It notes the long, narrow leaves, and, this is key, it observes that the plant structure suggests it's probably aquatic or semi-aquatic. It's just reporting the facts, no guessing.
And now, the brain takes over. It gets that text description. Remember, it never even sees the image, but it latches onto that one key phrase, aquatic or semi-aquatic. Using its deep knowledge base, it reasons that even though the leaves look like grass, the whole aquatic thing points straight to Cyperaceae, the sedge family. And boom, it nails the correct answer.
Okay, so the collaboration is cool, no doubt about it. But here's the million-dollar question. Can this small modular team actually go head-to-head with a state-of-the-art all-in-one giant like GPT-4o?
And the answer is a huge, resounding yes. Look at this. On MathVista, which is a really tough benchmark for visual math problems, the BEMYEYES team scored an incredible 72.7%. That is a full 7 points higher than the massive all-in-one GPT-4o. And this wasn't just a one-time fluke. You see the same pattern across a bunch of extremely difficult tests. The BEMYEYES team consistently outguns the all-in-one giant. It just goes to show this whole collaborative approach has a serious edge. But the most absolutely stunning result comes from MathVision. These are problems from actual, real-world math competitions. And here, the collaborative team scores more than 12% higher. That's not just a small improvement, that is a massive leap forward.
So what's the big takeaway here? Why does this collaborative, modular approach matter so much for where AI is headed?
Well, there are 3 huge advantages. First, it's way cheaper. You don't have to constantly retrain some behemoth model from scratch. Second, you preserve the pure reasoning power of the best text-only models. You let them do what they do best. And third, it's just so incredibly flexible. The minute a better brain comes out or a new kind of eyes for, say, audio, you can just swap it in.
Which really leaves us with this incredible thought. Maybe the future of AI isn't about building one single giant all-knowing brain, but instead about creating a symphony of specialists all working together in perfect harmony.